Guys, welcome to another video. Welcome back to my YouTube channel. Today we have an interesting problem to solve, a problem which is very fancy and very interesting. So let's see the problem and go through the solution together as always. So we have this system of simultaneous equations, something very unique. We have x squared plus y squared equal to 7. Then we have x cubed plus y cubed equal to 10. So if you want to use the method we know in solving simultaneous equation, either elimination or substitution directly like this, you are going to hit a brick wall. So the best approach is to use algebraic identities. So guys, before I continue with the solution, please, if you are new on this channel or today is your first time of seeing our videos on YouTube, please do well to join this community by subscribing and ensure that you turn on the post notification so that you can be notified anytime I upload a new video. Without any further ado, let's get started with this. So, solution. X squared plus y squared. This seems to be sum of squares. Okay, I will take the square of sum. So x plus y all squared, as we all know, is x squared plus y squared plus 2sy. This binomial formula is very famous. It's called the perfect square. So I will isolate x squared plus y squared. So x squared plus y squared is going to be x plus y all squared minus 2sy. Now, since x squared plus y squared is equal to 7, I can then write this equation to be x plus y all squared minus 2sy equal to 7. This is our equation number 1. I will do same for the second equation here. X cubed plus y cubed. Okay, this is sum of cubes. I will need to go look for the cube of sum. I also know that x plus y all cube, this is the cube of sum. You can actually either do this by direct expansion of x plus y multiplied 3 times, or you can use the Pascal triangle or binomial expansion. So either way, you are going to get x cubed plus 3x squared y plus 3xy squared plus y cubed. So for the sake of the problem we are solving, I will isolate x cubed and y cubed. I can write this to be x plus y cubed first. Take the cubes together. Plus, then for these two middle guys, I want to factor out 3sy. I'll write 3sy into x plus y. Okay? And I know again that x cubed plus y cubed is equal to 10. So I can then write this equation to be x, okay, plus y all cubed should not be I'm isolating these two. Okay, I've not isolated them. Okay, let me just repeat this. Is equal to x cubed plus y cubed plus 3xy into x plus y. Okay, I will isolate x cubed plus y cubed. So x cubed plus y cubed, I will take these two guys here to the other side. Becomes x plus y all cubed minus 3xy into x plus y. Like I said, x cubed plus y cubed is 10. So I'll then be having x plus y all cubed minus 3xy into x plus y equal to 10. This is my equation number 2. So we have done so well. The next thing I shall do is to arrange equations 1 and 2 so that we can solve them simultaneously. So we have x plus y all squared minus 2xy equal to 7. This is our equation 1. Nothing has changed. Then we have x plus y all cubed minus 3xy into s plus y equal to 10. This is equation number 2. Now, it's only a very hardworking mathematician that can solve this and get the answer easily. So, for somebody who want to ace his or her score in mathematics or want to become better in mathematics, the best thing to do is to use algebraic substitutions. Trust me, that's a better alternative. So I will say, let u equal to s plus y and v equal to sy. So you can see that this substitution will reduce the complexity, in outlook of this problem. More like we are refining them. So s plus y squared, okay, s plus y all squared, and we know that u is equal to s plus y. We'll take u there, u squared, minus 2xy, and sy is v. So that will be minus 2v equal to 7. I will call this equation number 3. Then, in the equation number 2, we'll be having u cubed. We'll be having, okay, you have u, which is s plus y, v, which is sy. We'll be having 3uv equal to 10. I will call this equation number 4. So, solving equations 3 and 4 simultaneously is actually better and easier to comprehend. So what I'm going to do now is to use the substitution method. I will make v the subject in equation 3, then substitute it into equation 4. Okay, from equation 3, we have u squared minus 2v equal to 7. If I take 2v, I'll have u squared minus 7. So therefore, v equal to u squared minus 7 divided by 2. So I can call this equation number 5. What I need to do, I will plug equation number 5 into equation number 4. This is going to give us u cubed minus 3u, u squared minus 7 all over 2 equal to 10. So we are actually plugging equation 5 into equation 4. So 3u will stay. In place of v, we will replace it with u squared minus 7 divided by 2. So I'll get rid of the fraction first by multiplying through by 2. I'll be having 2u cubed minus 3u into u squared minus 7 equal to 20. Okay, what I've done here is simple, guys. More like multiplying each term by 2, which is the LCM. 2 multiply u cubed will be 2u cubed. If I use 2 to multiply this term, 2 will cancel out. Then 2 to multiply 10, which is 20. So I will distribute this parenthesis. 2u cubed minus 3u multiply u squared, that will also be 3u, okay, this will be 3u cubed. Then negative 3u multiply negative 7, that will be 21u, everything equal to 20. So 2u cubed minus 3u cubed to give us minus u cubed plus 21u. I'll take 20 this to the left, becomes negative, equal to 0. Okay, the leading coefficient here is negative 1, which is not too proper or normal. So I will multiply through by negative 1. I will have u cubed minus 21u plus 20 equal to 0. Okay, with this, that's actually a depressed cubic equation or a depressed cubic polynomial. I am going to actually factorize this. If I use the rational root theorem, 20 divided by 1, the leading coefficient here is 1. Then I'm looking at 1, 2, 4, 5, 10, and 20. So because of the fact that this is factorable, no need to use synthetic division. I can factorize this. I will have to split 21 into u and 20u. So for negative 21, I'll be having u cubed minus u minus 20u, then plus 20 equal to 0. So you can see that if I add 20u and u, I'll get 21. In this case, negative u added to negative 20u, that will be negative 21u. So we've not altered the equation at all. So let me write this way. Then I'll factorize by grouping. So u is common in this first group. I will have u squared minus 1. 20 is common here. I will have u minus 1. Everything equal to 0. Now, u squared minus 1 is actually a difference of 2 squared. U all squared, 1 all squared. So difference of 2 squares, another famous formula. We take the sum of these two guys, then we take the difference as well. So for u squared minus 1, I will write it to be u plus 1, then u minus 1. I'll write negative 20 u minus 1, everything equal to 0. So you can see the beauty of this factorization. So you can see that the escort to u minus 1 here is negative 20. The escort to u minus 1 here are these two guys, u and u plus 1. So I will multiply u and u plus 1. That will be u squared. You multiply u squared. You multiply 1, that will be u. I will write u minus 1. I will write negative 20 u minus 1, everything equal to 0. So we've obtained our first factor, which is u minus 1. So I will pick out the outside terms. These two parentheses are the same. So I will pick u squared plus u minus 20 in one parenthesis, u minus 1, everything equal to 0. Okay, from the zero product property, it implies that u squared plus u minus 20 equal to 0 or u minus 1 equal to 0. So if u minus 1 is equal to 0, it implies that u equal to 1. So that's our first solution. Then our next concern is to factorize this big guy here, u squared plus u minus 20. Okay, two factors of 20 that can be added or subtracted to give 1. Okay, in this case, now it's going to be subtraction. That will be 5 and 4. Okay, I'll write for u squared plus u minus 20 equal to 0. So we have to factorize that. Then we are home and dry. So like I said, 5 minus 1 is, okay, 5 minus 4 is 1. So I'm going to be having negative 4 and positive 5. So if I multiply negative 4 and 5, that will give me negative 20. If I add them together, it will give me 1. So I will write u minus 4, u minus, okay, u plus 5 equal to 0. Okay? So it implies that u minus 4 equal to 0 or u plus 5 equal to 0. So if I take negative 4 to the right, it will become positive. Take 5 to the right, it becomes negative. So we have 3 values for u. So we have u equal to 1, we have u equal to 4, and we have u equal to negative 5. So guys, our target is to find the values of s plus y. So we recall that s plus y equal to u. So when u is equal to 1, we are going to be having, okay, when u equal to 1, it implies that s plus y equal to 1 is the first solution. So when u equal to 2, is there any need for this? Okay, let me write that when u equal to 4, it implies that s plus y equal to 4. And lastly, when u equal to negative 5, s plus y equal to negative 5. So guys, s plus y equal to 1, s plus y equal to 4, and s plus y equal to negative 5. Those are the 3 values of s plus y that satisfy the system of equation. So guys, we are done with today's tutorial. Please, if you have derived value of you are enjoying it or you enjoyed it, please do well to subscribe and turn on the post notification so that you can be notified anytime I upload a new video. See you next time. Bye.